Okay, so video 2, now we're going to go to the next level. Given collinear points R, P, and M, where P is between R and M, let RP equal x squared, PM equal 8x, and RM equal 20. Solve for x. So RP, because P is between them, plus PM equals RM. RP is x squared, PM is 8x, RM is 20. All right, x squared plus 8x minus 20 equals 0. Factoring, ladies and gents, factoring. All right, you got a quadratic. X plus 10 times x minus 2 equals 0. And my two solutions algebraically are negative 10 and 2. If this was your Algebra 1 class, that's all it would be, negative 10 and 2, and you're done. But it's not an algebra class, it's a geometry class. So what you have to then do is plug it back in. So what I mean by that is this. Here's R, P, and M. All right, RP is the x squared. PM is the 8x. All right. Now, and the RM, which is the whole thing, is 20. If I plug in 2, 2 squared is 4. 2 times 8 is 16. 4 plus 2 is 16. So 2 is awesome. The issue with negative 10 is this. Negative 10 times 8 would give me negative 80. Okay, and the problem with that is I can't have a negative value for a length. So when I plug it in here, 100 minus 80 certainly gives me 20. The problem is negative 80 can't be a length. So when describing negative 10, we call that extraneous. If you didn't go through that last year, an extraneous solution is one that works algebraically but does not work mathematically. All right? Now, an application of this, part 2, coordinate midpoint. Congruent segments, CONGRUENT, are 2 or more segments with the same length. Teachers note they're not equal. We don't call them equal because they're measurements. They have equal length. Defined as a point on a segment that divides a segment into 2 congruent segments. That is what a midpoint does. So a midpoint is like it seems to be in the middle. That is the symbol for congruent. Segment AB with midpoint M, all 3 points collinear, and AM equals MB. Again, when you give the 2 letters without any other symbol, we're talking about the measurement. All right? Example, given segment PR with midpoint Q. So there's P, Q, and R. And now they're the same length. You don't have to draw it that way, but that's the idea. So PQ equals 6x minus 7. QR is 5x plus 3. All right? Well, they don't give us the full length because we know now the 2 of them are equal to each other. That's the difference. So 6x minus 7 equals 5x plus 3, minus 5x from both sides. X minus 7 equals 3. Add the 7 to both sides, and x equals 10. But again, make sure you answer what they asked for. Oops. They didn't want x. Okay? They wanted the length of PR. So when I plug that in, 5 times 10 is 50. 50 plus 3 is 53. 6 times 10 is 60. 60 minus 7 is also 53. Well, it's good that we're doing this because it's checking our work and they come out to be the same. And then to get the length of PR, we either take 53 and add it to itself, or most people are just going to multiply by 2, and you get 106 units, since they don't give us a label. All right, life is full of challenges. Given segment PR with midpoint Q. So the setup is the same. 3x squared minus 5x equals negative 17x. All right. Now I'm going to add 17x to both sides. 3x squared equals 12x. Oops, plus 12x equals 0. All right. Now it's a binomial with both of them having x in it, and 3 goes into both. So 3x times x plus 4 equals 0. I factor out a GCF. For those of you that don't recall, whenever there's a variable on the outside, one of your solutions becomes 0. And from the problem we did over there, the 0 property, we have to make this 0, so the opposite of positive 4 would be negative 4. So our 2 solutions are 0 and negative 4. Well, If I plug in 0, both segments become 0. So that is another example of an extraneous solution. Now, it is possible that both situations are extraneous, but when I plug in -4 to QR, -17 times -4, negative times a negative turns that back into a positive, which is 68. All right? -4, 16 times 3 is 48. -4 times 5 is 20. That's also 68. And they come out to be the same. And since PR is the sum of those segments, like we showed in the other example, our final answer is the sum of 68 and 68, which is 136 units. All right, this is detailed in the video, by the way, if you need more explanation. Now, the last part of today's lesson, all right, coordinate midpoint. Given points A, x1, y1, and B, x2, y2, the midpoint of AB. So now we're talking about this. Talking about two segments. Endpoints, A and B. And then the midpoint is somewhere in between them. Well, to find its coordinates, okay, so M is a midpoint. Remember, this means AM is congruent to MB. To find the midpoints, it would be x1 plus x2, here's your formula, over 2, y1 plus y2 over 2. Remember, the numbers don't mean anything numerically. They're just indicating different points. They're subscripts. So if we look at this equation, we'll notice all we're doing is adding and dividing by 2. Well, when we add two numbers and divide by 2, all right, we call that the mean or the average of the coordinates. The mean or the average of the coordinates. All right? So that's all we're going to do. So if we flip over the paper and we look on the right-hand side of the notes, you'll see the answers are down there. All right? Find the midpoint of the line segment with the given endpoints. All right? So when we add them up, -5 plus 9 divided by 2, comma, -9 plus 1 divided by 2. -5 plus 9 is 4. 4 divided by 2 is 2. -9 plus 1 is -8. -8 divided by 2 is -4. So 2, -4 is the coordinates. Again, all you're going to do is add up and divide by 2. All right? Now, number 2, just so you know, they aren't always. If we do 0 plus -3 and divide by 2, we get -1.5. That's fine. If you want to write it as -1 1/2, that's fine. -5 plus -10 is -15. Half of -15 would be -7.5. All right. Number 3, notice the y's are the same. Whenever you have a coordinate that is the same, that means the coordinate of its midpoint is also the same. That is, of course, a horizontal line. And then to do the other part, 5 plus -6 is -1. So now we have -1/2. So our midpoint would be -1/2 and 2. Again, the answers to that are in the bottom. All right, their answers, they have it in fractions. Now the last thing. Working backwards, given one endpoint in the midpoint, find the coordinates of the other endpoint. All right, there is a formula, all right, which means xm, ym equals x1 plus x2 over 2, y1 plus y2 over 2. Okay? If you want to, when you're in class, I will gladly show you that. However, I wouldn't recommend that because it gets complicated with all the subscripts. I would recommend number 2 or number 3. The visual is you graph. All right, so we're going to graph the points. All right, when we do the procedure, okay, that procedure is this. Number 1, take the coordinates of the midpoint and multiply by 2. The second part of that is you take the coordinates of the endpoint and you subtract from number 1, whatever you get. All right. Myself, I like the visual way. To me, it's the easiest way to do it, but not everybody's visual. So if you want, we'll go through both of that with this problem. Given segment AB with midpoint M, A has coordinates -4, 8, and M has coordinates 2, -2. Find the coordinates of B. All right, so A has coordinates -4, 8, so I just get an idea of where that is. And M, the midpoint, is at 2, -2. All right, so we're just going to take the idea of the number line, which we talked about earlier, and go from there. So when I go from -4 to 2, okay, that means I went over 6. So that means to get my other endpoint, I go over another 6. So you're just repeating the process. And the same thing with the y's. I'm going from 8 down to -2, which means I go down 10, which means to get my other endpoint, I go down another 10. All right, well, if I go over 6 from 2, I'm at 8. I'm just counting. All right? And if I go down 10 from -2, I'm at -12. So my other endpoint is at 8, -12. Try to get it all on the screen so you can see the whole thing. So again, how far I go over, I just repeat the process. How far I go down, I just repeat the process. Now, for those of you that like to do it without the visualization, we'll take the same problem. All right, so now we have A, the endpoint, is -4, 8. And the M, the midpoint, is 2, -2. Okay, basically what we're going to do is we're going to take the midpoint and times its coordinates by 2. 4, -4. Boom, shakalaka. I'm then going to take the endpoint, put it underneath, -4, 8. I'm going to put a subtraction sign. So that means I'm going to take the values of the doubled midpoint and subtract that. 4 minus -4 turns into 4 plus 4, which is 8. -4 minus 8 is -12. And would you look at here? The two answers are exactly the same. So it's up to you. If you want to practice those, 4, 5, and 6 are on the other side. The answers are there for you to practice. And that's about it for this lesson. So Monday we will post the assignment that goes with it. All right, and hopefully you should be good to go. Have a good weekend, everybody. Be safe.